Hello, this is a demonstration of the ESP32 ultra low power modes. I have here an ESP32 Thing from Sparkfun, which I currently have just a little bit of code to set up the deep sleep functions and to talk to this ePaper display. I specifically chose this display despite its expense because when not updating the screen, it uses much less current than something like an OLED, for instance. Because even right now, with no power to the circuit, it still displays the name of my device. So when I power it on, the ESP right away uses 40 to 50 milliamps. When Bluetooth is on, actually uses somewhere upwards of 70. What it does is when it boots up, it updates the screen and sets it to MagSpoof BT, and then shuts right off. As we can see here, it's only using 2.67 milliamps. That's mainly because there is a LED on the board still, and that draws a bit of current. If I was using something like an Adafruit Fetter with a W-Room module on it, this one does not have a hardwired power LED. So the only things using current are the chip itself, and maybe the USB programmer chip, which it would be great if I could have that turned off. I have measured its current output, and it usually consumes little over an amp with this display connected. So what I have to pull it out of deep sleep is, well, what deep sleep is it shuts off the main processors completely and activates what's called an ultra low power coprocessor. And that coprocessor handles waking up the chip after a set time delay, or like a button interrupt or something like that. What we have set up is instead a button interrupt instead of a timed delay. That way when I press the button, it'll wake up the device, run the action depending on what button I clicked, and then power right back off. So what I have it programmed to do right now is when I press the button, it will send to the display what button I pressed, and then shut immediately back off. So I have GPIO 32, 33, 34, and 35. And these are actually also set up for capacitive touch. So I don't have to click anything, I just have to touch my finger to one of these buttons, and it starts using a bunch of current and updates the display and tells me that I touched GPIO 32. If I do the same for 33, it'll pick that up, activate the circuit, and say that I got GPIO 33. And we'll watch as the milliamps drop down to 2.67. Right there. So we'll go through and hit GPIO 34. It'll update the display. Then wait for it to turn off. There it is. And I'll activate a button again, and we'll get GPIO 35. And there it goes. So, with the device I'm actually developing for this, I'm probably not going to actually be updating the display on every button press. I plan to only do that on one of them, because I'm going to dedicate one button to activating the Bluetooth functions of the device so that I can send and receive data to it for a short amount of time. The other three buttons will be activating an extremely quick action that will power on, run it super quick, and then shut right back off. So I'm probably not even going to update anything about the display on those button presses. So I think one thing I would have wanted to do is add a counter for how many times it's booted up, because that way you could see how many times. Because there is a way to store memory in the ultra low power coprocessor so that you can keep track of how many times you've woken up the CPU by tracking how many times you've booted. So the code is rerun every time you activate one of these buttons and bring it out of deep sleep mode. I could probably provide some code if anyone wanted to see it, but what I have is a variable that is defined as being part of the ultra low coprocessor memory, and then I just count it up every time it boots. And when it's a first boot, so I'll turn it off and turn it back on, it actually prints out the magspoof BT text. Because otherwise, if I don't, if I spit that out every time it boots up instead of checking to see which number of boots I'm on, then every time I hit one of these buttons, it's going to say that string and then override it with whatever I programmed these buttons to do. So when I hit the button, instead of writing the magspoof BT first and then doing the GPIO number, it just goes straight to the GPIO number. So, a handy way of creating some simple code paths for your ESP such that you use as little current as possible while still allowing some fairly complex functions, which is why I would set that up to enable Bluetooth and do all those kinds of things. So, thank you much for watching. Sorry this went for 6 minutes or so, but I had a little bit of data and information to share. So, thank you.